Okay, and another parent function, and this is going to be y equals 1 over x. Sometimes we call this a reciprocal function. We need a few more points on this, but once you get the idea, it's not too bad. So first of all, again, we're going to analyze our horizontal vertical shift. So here's the opposite sign, so my horizontal shift will be positive 3, and my vertical shift, same sign, will be positive 2. Okay. And then I'm going to use my shape equation, which is going to be 1 over x. So I'm going to try some different values. So these are the values you have to use for this. So they actually have 6. Have to use 6 because it's a little bit more complicated function. So we can use x equals, we can go 1 half, 1 and 2, and then negative 1 half, negative 1, and negative 2. And 1 over 1 half is just 2. 1 over 1 is 1, and 1 over 2 is 1 half. And again, 1 over negative 1 half is negative 2. 1 over negative 1 is negative 1, and 1 over negative 2 is negative 1 half. So first of all, let's find my shift. So my shift's going to be 3 to the right up 2. Now this is asymptotic. You know, we saw the basic parent function 1 over x is asymptotic to the x and the y axis. So you have to write your asymptotes once you have your shift. Because this is my new 0, 0. So normally the axes are the asymptotes. We kind of draw almost like new axes. So we draw. And always draw your asymptotes in dashed lines. And that's going to really help us that's going to help give us the shape of the curve because it's going to conform to those asymptotes. And now I'll put my points in here. So if I go over 1, if fx is 1 half, from here I go over 1 half, I go up 2. Over 1 up 1, and over 2 up a half. And then I go back a half, down 2, back 1, down 1, and back 2 to the left, down 1 half. And you can see those points, and then you use your asymptotes, so you draw lines that are getting closer and closer, make sure they get closer and closer, not away from those lines. And they approach those lines, but they don't touch them. So make sure they're not moving away from the lines, but they have to get closer and closer to the lines. And the same thing down here. And there's your reciprocal function like that. Oops, got to watch out. It looks like this arrow's moving away. We always wanted to get closer to the line, not away from the line. So something like that. It's got to be getting closer to that line. Okay? When you put arrows in, sometimes it kind of corrupts your sketch there. All right? And that's all you got to do. So you do need 6 points, but they're real easy points. All right, let's try another one over here. So my horizontal shift is going to be negative 1, opposite sign. Vertical shift is same sign, so it's going to be negative 2. And my shape equation is the same thing. Now just y equals, my shape equation is y equals 1 over x. So I can use the same points here, so I don't have to redo that. Find my shift, so I'm going to go 1 to the left, down 2, 1 to the left, down 2. And once I do that, I have to put my asymptotes in. So again, use your dashed lines. So there's your asymptotes. And then put your points in, your key points. So from here I go 1 half up 2, 1, 1, and 2, 1 half. And I go back 1 half, down 2, back 1, down 1, and back 2, down 1/2, -2, -1/2. And again, use those asymptotes as you get closer and closer to the asymptote. It gets closer and closer to the line. Okay. Next time I do this, I might maybe use blue dash lines for the asymptote so you can see your curve better, because it starts to run in because they're both pencil. Okay? But I do use pencil because I can mess this up, so I want to be able to erase it. Make sure I keep those asymptotes going towards the line. Okay? And one more. So let's take a look at this and my shift. First of all, same idea. My horizontal shift will be opposite sign, so my horizontal shift will be +2. My vertical shift will be +1. And then my shape equation is going to be a little different now because it's going to be y. My shape equation will be y equals -1 over x. So I'm going to use my same points. 1/2, 1, 2, -1/2, -1, -2. This is the only one that we don't use 0, because it's actually undefined at 0. When x equals 0, we have 0 in the denominator. That's a restriction on the domain. Remember that good stuff. So the reciprocal of 1/2 is going to be 2, but it's going to have a negative, so it's going to flip the sign, so it's going to be -2. -1, -1/2. And this would be 2, but then it's going to be +2 because it's negative and negative is a positive. So I got a -2, +2. +1, +1/2. So it just reverses the signs when we put this in. And then I find my shift, my translation of the axis also. It's going to be +2, +1. So I'm going to go over 2, up 1. +2, +1. Then I'll draw my asymptotes, just dashed lines. Try to keep them on the lines. I'd use a ruler if I would have brought one out to where I'm at. Okay, and then I'll put my key points in. So I'm going to go 1/2 down 2, 1/2 down 2, 1, 2, 1 down 1, and 2 down 1/2. And then I'm going to go -1/2 up 2, -1 up 1, and -2 up 1/2. And you can see it's kind of flips the quadrants now. In other words, this one was in, if we remember our 4 quadrants, 1, 2, 3, 4, this was in quadrant 1 and 3, and this is going to be quadrants 2 and 4. And remember, it gets closer and closer to those asymptotes, but it never touches them, but as you get farther and farther out, it gets closer and closer. There you go. Oops, sorry. Excuse me. Something like that. Okay? So, use these points from my shift. 2 to the right, up 1. And like I said before, this one is in quadrant 1 and 3. Quadrants 1 and 3. This is in quadrants 2 and 4. Okay? Alrighty, so maybe that will help you guys out a little bit.